Okay, so we are now on page 6 of your notes. It starts with this review, so I want you to try these 5 questions. Come back after you're done, pause your video, and see how you did. Right? Okay, so question 1 says, what does bisect mean? Bisect is bis 2 and sect is cut. So it's to divide into 2 equal parts is the answer. Use the diagram with the right to fill in the blank. AB bisects what? So AB cuts RS in half. So you should put RS. It's also true that RS bisects AB. So that would have been fine too if they had written it that way. Underlining the correct word, a transversal intersects 2 or more coplanar lines. Use the definition of a transversal. So looking at our picture over here, the transversal is the line that intersects 2 or more lines, so that's going to be P. And then we're supposed to draw another transversal and label it S. You can just draw another line in that intersects 2 or more lines and label it S. Okay? You could have drawn your line over here. You could have gone over this way. As long as it hits at least 2 lines, you're good. Okay, so our first theorem now is that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so if this angle is labeled as X, and the consecutive angles would be these. Those are the ones that are right next to it. Remember, opposite angles are the same, so this one would also be X. But these are not also X's. There's something else, so I'm going to name them Y. Okay, so this theorem says that anytime you add up 2 consecutive angles, so consecutive to the X is either this Y or this Y, that it'll be supplementary. So X plus Y will be 180. Okay, so you could use these two. These two would be add up to 180 because they're also X and Y and they're next to each other in the parallelogram. So another theorem is that if you have a parallelogram, then the diagonals bisect each other. So if I draw in the diagonals here, this is just like up here where they cut each other in half. So that means that will be the same and this will be the same. But notice I did not use the same markings because we have 2 sets of segments that are congruent. So they're not necessarily all congruent to each other. Okay, so let's try some problems. For this one, it looks like I forgot to put a picture down, but there is enough information actually to solve this one. So it says in a parallelogram, PQRS, angle P is 4 times the measure of angle Q. Find the measure of angle P. So it probably would help for you to draw a picture of parallelogram PQRS, because we need to know if those 2 angles are across from each other, if they're next to each other. So it says angle P is 4 times the angle Q. So whatever angle Q is, I know that I have to multiply it by 4 to get angle P. Okay, so these 2 angles are next to each other. So we're going to use this theorem here to figure out what X is. So they're not equal to each other. They'll add up to 180. So X plus 4X equals 180. Okay. Combine like terms, you get 5x is 180. Divide by 5, x is 36. All right. 15, 3, yep. So x would be 56. And that is the measure of angle Q. So angle Q is 36 degrees, but the question says find the measure of angle P. So angle P is 4 times this, so 36 times 4. The measure of angle P is 36 times 4. And it would be 120 plus 16, which is 136. That's not right. What did I do wrong? Yeah. 4. Come on. 4 times 36. I put 34. It's 144. This should say 36. So this is 144. And I knew that I was wrong because these two have to add up to 180. And so the two numbers that I had there did not add up to 180. So this is your final answer. Okay. On the back page, this example 11 is harder than I would ask you to do on a quiz, and I don't think there's anything that's difficult on the homework. But you will have ones similar to this. It's just the algebra won't be as difficult as this one. So I'm going to use pencil just in case. So for this one, we're supposed to find the values of x and y. As you can see, they're labeled on diagonals, and we just learned that the diagonals bisect each other. So that means the two pieces of this diagonal are the same, and the two pieces of this diagonal are the same. So starting with PR, I would have 2x equals 3y minus 7. Okay, and on the diagonal QS, you're going to have y equals x plus 1. Okay, so the reason this is so hard is it's a system of equations, and I haven't made you do any of those this year. So for your homework, you need to know how to set these up so that these two are equal to each other and these two are equal to each other, and then solve. On your homework, it'll probably be more like 2y equals 3y minus 7, so you have the same variable in both. But this is a pretty good review of systems. You're going to have to do them again next year, so let's go through it anyway. For this one, the easiest way to solve this system is using substitution. Since we know y is the same thing as x plus 1, I'm going to take this x plus 1 and substitute it in for the y up above. Okay, so I'm going to rewrite this equation. Instead of y, I'm going to put x plus 1. So we get 2x equals 3, ran into the y. I'm going to put x plus 1 there, and then the minus 7 to finish that equation. Okay, so this is much easier to solve. We only have one variable in it. So we've got 2x, and I need to distribute. So that would be 3x plus 3 minus 7. Then combine like terms. 2x equals 3x minus 4. Then I would subtract 3x from both sides and get negative 1x equals negative 4. And then divide by negative 1, x equals 4. Okay, then you use this in one of your original two equations to solve for y. I think the second one would be easier. So substituting x equals 4, we get y is 4 plus 1. So y is 5. So your answers are x equals 4 and y equals 5. Okay, let's try the next one. So for this one, find the coordinates of the intersection of the diagonals with those vertices. So first, draw in that parallelogram. So A is at 1, 0. Oh boy. And not off to a good start. I did 1, 1. 1, 0 is here. B is at 6, 0. C is at 5, 3. And D is at 0, 3. A, B, C, D. So this parallelogram looks like it is right here. Okay, so if I was to draw in the diagonals, it looks like right there. And it meets somewhere over here. My lines may not be straight, so I can't really trust where I put that dot. Maybe it should be at 3, 1 or up here at 3, 2. I'm not really sure. So, but I do know that the diagonals bisect each other, so they cut each other in half. So this point where they intersect is the midpoint of both of the diagonals. So we're going to use the midpoint formula. If you don't remember that one, right, midpoint. It goes x1 plus x2 over 2 and y1 plus y2 over 2. Okay, then you just choose your favorite between the two diagonals. I like B and D because they both have zeros in them, and that makes life much easier. So if I use B and D, B will have the x1, y1, and D will be x2, y2. So putting that into the formula, we will have 6 plus 0 over 2 for our x's. We'll use these two x's, and then for the y's, we have 0 and 3. So 6 plus 0 is 6, and 0 plus 3 is 3. So the midpoint is going to be at 3, 1.5. So let's check how close that looks with our picture. 3 is here. Looks like it's going to be about right here. So I was off just a little bit with my picture. But then, they're actually going to cross right there. Okay. The next one, the last thing we're doing for this video. We are given 3 vertices of a parallelogram, and you have to find the last vertex. So for this one, D is at -1, 4. E is at 2, 3. F is at 4, -2. So we have D, E, and F. So if I connect D, E, F, I'm thinking G has to be somewhere over here somewhere. I know that the next line I would draw would be from F to G. Okay, so what you're going to do is use the idea of slopes to find that parallel slope. So parallel slope has the exact same slope. So if I go E to D, that should be the same slope as F to G. Okay, so to go from E to D, I'm going to give myself a note. I'm going from E to D, and to do that, I go up 1 and backwards 1, 2, 3. So I went up 1 and backwards 3. Okay, so to go from F to G, you do the same thing. You'd go up 1 and backwards 3 because it's parallel. So from F to G, F is here, so I'd go up 1, backwards 3. 1, 2, 3, and I'd end up right here. So that's got to be where G is. So now if I draw in the rest of the parallelogram, it sure looks correct. This will have the same slope as this. It's down 1 over 3, down 1 over 3. D, G, and E, F should have the same slope. So that would be down 1, 2, 3, 4, 5, and over 2. So down 5 over 2, this one's 1, 2, 3, 4, 5, and over 2. So we can check our work. Those sides are parallel as well. So the last part says find the coordinates of vertex G. I found that G was at 1, -1.